This second lab, I'm going to begin with an overview what this lab is about. We've seen that R is a functional language. Everything that happens in R happens as a consequence of as a function, and we've seen 3 of them. They're shown there. Every time you load up R, you get a number of functions that are built into base R. But those only go so far. And what we will rely heavily on in this course are additional packages built by data scientists. And these additional packages come with them functions, some built-in data frames, and some documentations. And one of the really important packages we're going to be using is ggplot2, and we're going to use that package today because that will give us access to the data frame MPG. So, the first step in data visualization is typically data manipulation. And you have to be really good at that if you want to be really good at data visualization. In the last lab, we talked a bit about data frames. And in this lab and in all the rest of the labs, we're going to be working almost exclusively with data frames. Because by doing so, that will enable us to work with these third-party packages in a very efficient way. So, this is a really important slide, and this slide shows the data frame MPG. And here we have the 11 variables that are present in the data frame MPG, and that data frame reflects some information on vehicles, motor vehicles. So what are these variables? Well, we got the manufacturer. There's 15 of those. We have 38 different models. Displacement is the size of the engine, the year in which the car was built, either 1999 or 2008, the number of cylinders, the drive, 4, rear, or front wheel drive, city and highway mileage, and the type of fuel. This column is really important. And in this column, we see the type of variable. And we've got characters, and we've got a num, and we've got a bunch of int. And we can come down here and see that these variable types fall into one of 2 categories. Either this category or this category. And the first category, we've got either characters or factors. They behave very similar. Now, in our particular data frame MPG, we don't have any factors, but we'll be seeing those later on. If you've got something that's a character or a factor, the variable is a discrete variable. So if we come up here and think about manufacturer or model, for example, they can only take on discrete values. The notion of quotes, if we look at manufacturer or if we look at model and we look at some of the levels, like there's our Audi, notice that it's in quotes. Audi is in quotes, or the model A4 is inside quotes. So that's these guys here. Now let's think about the ints and the nums. The ints or the nums, they are continuous variables. So if we think about something like displacement, the size of the engine, that's going to be a continuous variable. Or city or highway mileage, that's going to be a continuous variable. Also note no quotes. No quotes. So in contrast to manufacturer and model, where you see these little quotations, if you look at city and highway mileage and the different levels, there's no quotations surrounding them. Why is this distinction? Why is this distinction between these 2 groups of variable types so important? It's because everything that happens in R happens as a consequence of function, and the function is likely going to expect something from this group or something from this group, and if you feed it something from the wrong group, nasty things are going to happen. So, next topic is this notion of chaining commands. How we're going to link commands together to get things done. So let's assume we're going to begin with a data frame that we just saw, MPG. And we want to make a new data frame called MPG1 that's going to be pretty much the same as MPG with the following changes. It's only going to have two variables, drive and city. It's going to be filtered so that the only records that are in MPG1 are going to be those for which city mileage is greater than 22. And then I want to change the value of city. I want to update it by increasing it by a value of 10. Here's a bunch of code that would enable me to do that. And don't pay very much attention to this code because we're not actually going to use it. I just want to focus on the process. And one way we could accomplish our goal would be to start off with MPG, write a bunch of code, make this new data frame df1, use that as a starting point, write a bunch of code to create df2, use df2 as a starting point, write a bunch of code, and create MPG1. I'm not focusing on it because that's not what we're going to do. This slide shows what we're going to do, and it involves this process of chaining. So, my goal is to produce MPG1. And here you see the assignment operator. And what that means is, what's MPG1 going to consist of? It's going to be assigned everything that's to the right of this assignment operator. There's another way to think about this. An alternative way to think about this is that in order to create MPG1, I'm going to start with MPG, and then I'm going to do a bunch of stuff. And that's where this operator comes in. This operator is referred to as the piping operator. And it consists of the percent sign, the sign here, another percent sign. A really useful keyboard shortcut is Control-Shift-M. So every time you see this piping operator, what should go through your mind are the words "and then." So, to create MPG1, there's my assignment operator. And if you want a keyboard shortcut for that, there's the keyboard shortcut. It's worth knowing that you could use an equal sign rather than an assignment operator, but that doesn't appear very elegant, so normally we don't. But anyways, to create MPG1, I'm going to begin with MPG and then. So every time I see this, what goes through my mind are the words "and then." So I start off with MPG, and then I use this particular function to retain only those two variables. Then I continue on with the piping operator, and then I filter to retain the records that I want, and then I continue on to create or update the value of city mileage. One thing to note, all this code here could have been created, could have strung that out as a single line. But I decided not to do that. I decided I wanted to have 3 separate lines because there's 3 separate operations that I want to perform. By leaving the piping operator at the end of each line, that was a signal to R to keep on going. There was more code that needed to be evaluated.